Yes, good afternoon, all of you. So today we are going to discuss about the origin of electrode potential. So here, first of all, what is electrode potential? How many types of electrode potentials? All these things will be discussed first. First, what is electrode potential? Whenever the electrode is dipped in its own salt solution, a potential will be developed at the interface of electrode and electrolyte is called as the electrode potential. So here, for example, a electrode is dipped. This is a any electrode. It may be you can take it as a zinc or copper, whatever it may be. You dipped in the electrolyte. So when dip in the electrolyte, what happening is some potential will be developed at the interface of the electrode and electrolyte. So whenever the potential developed, either gain of electrons or loss of electron takes place. So the tendency to lose the electrons is called as the tendency lose the electrons. Which tendency? The tendency of the electrode to lose the electron is called as the oxidation potential. The tendency to gain the electrons, the tendency to gain the electrons of the electrode is called as the reduction potential. Thus, two types of potentials are there. One is the oxidation potential, another one is the reduction potential. So for example, here, if we see, if any electrode is dipped in its own salt solution, what happening? First of all, the zinc or zinc sulfate solution, here I am taking the zinc electrode. It is dipped in the zinc sulfate solution. So then what will happen? The first of all, a potential will be developed. So zinc is dissolving and zinc plus 2 ions formation will takes place. And where the electrons will go, they will be present on the surface of the electrode only. They left the electrons on the surface of the electrode. So thus this electrode gets the negative charge where the zinc ions are coming into the electrolyte and electrons are left over on the electrode surface only. So the electrode gets the negative charge. So due to the negative charge, what it will do? It will attract the opposite charged ions. So what are the opposite charged ions? Zinc plus 2 ions are opposite charged ions. Those are positive charged ions. So immediately due to that, it will attract the positive charged ions and they will present surrounding the electrode. Thus, negative, positive electrical double layer formation will take place. The electrical double layer formation will takes place. So the electrical double layer, first time it is discovered by the Helmholtz. So the electrical double layer can be called as Helmholtz electrical double layer. So in the same manner, here if I take the copper electrode, copper electrode dipped in the copper sulfate solution, then what will happen? The copper sulfate is having the copper plus 2 ions, which they will gain the electrons from the copper electrode. So copper will be deposited on the copper rod. So then what happen? The copper will lose the electron, so it will get the positive charge. So whenever it get the positive charge, it will attract the opposite charged ions. So the what are the opposite charged ions here? Sulfate ions. So it will attract thus a positive, negative, positive, negative. Electrical double layer formation will takes place. That is called as the Helmholtz electrical double layer. So to diminish this electrical double layer, suppose if you're connecting through the wire, both the electrodes, if you're connecting through the wire, then what will happen? The electrons will flow, these electrons will flow through the wire from the anode to cathode. Thus what happening? Whenever the cathode receive the electrons, the positive charge will be diminished. Whenever the positive charge is diminished, automatically the sulfate ions also will go back into the electrolyte. Thus, the Helmholtz electrical double layer will be diminished. In the same manner, here at the anode or zinc electrode, the negative charge is there. So the electrons are here, they are moving from anode to or zinc to copper. So immediately, whenever the negative charge is diminished here, the positive charge of zinc ions will go back into the electrolyte. Thus, the Helmholtz electrical double layer will be disappeared. So, okay, what will happen here? In the anodic of cell, the zinc plus 2 ions number is more. That means overpotential is developing here. The cation overpotential is developing here. In the same manner, in the copper sulfate, in the copper sulfate, copper plus 2 and sulfate minus ion 2, these two ions are present. Where copper plus 2 ions are depositing on the copper rod, only sulfate ions are remaining in the solution. Thus, the number of sulfate ions number will be more. So whenever the sulfate ion number is more, here over potential developing here. So to eliminate this over potential, we need to do here to eliminate the over potential. What we are doing here, connecting through the salt bridge. Whenever you connect through the salt bridge, whereas in the salt bridge, KCl solution generally we are using. So when you use the KCl solution, where the zinc off cell require the negative charge ions, where the chloride ions will move into this off cell, and in the same manner the copper off cell require the positive charge ions because sulfate ions are more, so the positive charge ions are moving into this. Thus what will happen? The electrical neutrality taking place here, that means the over potential is eliminating by the salt bridge. This is about the origin of the electrode potential as well as the elimination of the over potential or the importance of the salt bridge we can understand here. Here if you see this zinc electrode is connecting through the voltmeter and it is displaying the volts. In here this is the copper where it is connecting through the voltmeter. Salt bridge is used. Then what happening? A potential is developed. That potential difference will be developed. In between the what is the difference between potential difference between zinc and copper will be displayed in this voltmeter, that we can see that. This is about the origin of electrode potential. Here oxidation potential, reduction potential you can see, and here what is the different definitions also you can understand. What is the reduction potential? What is the oxidation potential? You can see that.